Hey, so thank you everyone for being here. My name is Kate and I'm a Ruby developer and one of the organisers of Rails Girls here in Melbourne. And today, Rails Girls is awesome. If you do not participate, please participate. So I organise that and I'm a Ruby developer and yes, I'm talking to you about automation tooling and basically how to stop it from ruining your life. Or at the very least, fingers crossed, your job. I have a really boring Twitter handle, like you can see it up there, @KateDeutcher, if you want to get in contact with me. And just to let you know, I'm going to be putting up all the notes and references from this talk online and tweeting the link to it after. So if you don't like taking notes like me, or if there's something you want to check back on, please feel free to grab it all later. So, firstly, a little bit about me. Most importantly, as was said before, I have two corgis. Their names are Jean-Luc Pecorg and it gets better, Leia Corgana, number 2. But other than that, I also work at this place called REA, where if you haven't heard of us before, we built the website realestate.com.au. Now, as I said, I am a Ruby developer, but about a year ago, I moved into what we call a delivery engineering team at REA. Now, this team is responsible for helping all of the other developers find good ways to build, package, and deploy their applications. Now, some of that is tooling, but we also do general guidance, developing patterns, and providing training as well. But for this talk, we're going to be focusing just on that tooling aspect. So, when I talk about automation and automation tooling, you might be wondering, well, what actually is that? Well, these are just pieces of software that are there to automate some part of the software delivery or development process. In other words, they're transforming those steps that would otherwise be manual into one that's automatic. So you can kind of find them in the wild doing things like bringing up your dev environments, managing your CI pipelines, or deploying your application to your chosen platform. The tools themselves vary heaps, so you can find some that are as small as a script and others that are as big as almost offering a platform as a service. I kind of like to think of them as little Lego blocks that can be clacked together to form a common base between all of your different systems. So that all sounds cool, but obviously building this tooling takes time and effort, and you might be wondering what prompted REA to invest so heavily in it. Well, the truth is that we kind of had to. There wasn't much choice, and it really came down to one thing, which was growth. So the number of engineers at REA has been growing really rapidly, and this rapid growth has kind of pushed us into embracing microservices as well. So that means that on top of having our systems developed on by a vastly larger number of people, we've also got a vastly larger number of systems. So questions that were coming up previously how can I bring up my development environment, how can I deploy my application, they were just happening way more often than they used to. And solutions that maybe used to work, I have really great documentation to bring up this development environment, or maybe you have that person on your team who can sit with you and help you through if you have a problem with your deployment. Well, those just weren't scaling at all. So if we look at the actual numbers, REA currently has about 620 engineers. And they're covering 580 systems. Right? So you don't have to be a mathematician to figure out that that is almost one engineer for every single system. And lots of these are deployed in different environments as well. So that's not deployments, that's just apps. So having maintaining this ratio would actually be completely impossible for us if we didn't invest in some sort of tooling. But the benefits that we've seen since introducing it have actually been really great. So we have one-step tests, one-step builds, and one-step deploys for far more systems than we used to, which means that there is almost no margin for error in these steps. And that actually translates to developers being far more confident in the delivery process and how long it's going to take them to get new things released. Providing automated solutions to common problems also means that every team doesn't have to go around solving the exact same problems multiple times, and developers can spend more time developing apps. We also try and make our tooling as language and framework agnostic as possible, so it can be used over a wider variety of systems. For us, this has been really important as we've been scaling out our after-hours like pager roster. So learning a single deployment tool can help a developer deploy like hundreds of different systems. So now that you know all about automation tooling and how awesome it is, hopefully, let's get dug into how you can actually build it. So there are three main patterns that I have seen during my time at REA for building this tooling. So we're going to have a look at each one of those patterns. Then we're going to examine an example of the pattern, and then what applications it can be used in. So what problems can this tooling be used to solve? All right, first pattern. This one we call the Swiss Army knife tool. So this is a tool that combines multiple individual functions behind a single simple interface to provide a kind of one-stop shop for your delivery or development process. Now, for an example of this, we're going to have a look at a tool called Kubernetes. Now, I kind of tried to go on their website and steal a description of Kubernetes and found that they describe it as an open source container orchestration tool. And I thought that like if you have never heard of Kubernetes or containers or clusters before, it might be like a bit of a stretch to understand that. So you get my layman version instead, which is it is a tool that manages a group of servers and gives you a simple API to deploy services onto those servers. So what does that look like? Well, let's deploy an application with Kubernetes. I can just run kubectl run hello world, image hello world, and that's it. Like my application is now deployed. That was almost too easy. So let's try something slightly harder. Let's say hello world has become really popular and I need to scale up to meet demand. Well, again, I can run a single command, kubectl scale deployment hello world replicas 4, and I've now got 4 instances of my application running. So if we think about those commands, what is it that makes Kubernetes a Swiss Army knife tool? Well, firstly, I was able to perform my task, which in this case is deploying and scaling my application, with the minimal amount of knowledge. Because these tools focus on providing such a simple interface, they're also inevitably like very opinionated. So like I didn't even need to know where my application was being deployed or write any configuration. I just defined the things I was interested in. So in this case, that's what my application is, how many I want running, and assumed that the tool was going to make all of those other decisions for me. Finally, the amount of decisions that this tool is making is heaps. So like, if you think about it, it is orchestrating that deployment across multiple servers, managing all the resources like CPU and memory, networking to my application so requests can get there, and monitoring the app as well so like we know that it's healthy and actually running. So with that in mind, like when should you be building a Swiss Army knife tool and what problems can it be used to solve? Well, these tools are really designed for speed. So they're designed to enable developers to perform their task as quickly as possible without having to make too many decisions that might slow them down. So they're simple and intuitive to use, which means that you're not going to have to invest a lot of time in learning how to use them. There's also only a limited number of ways that you can actually interact with this type of tooling, which means that like, it's going to be quite consistent across all of your different applications. But the things that make this tooling so great is also kind of what makes it so difficult to work with. Because like, unfortunately, engineers are smart and they have opinions, often lots of them. So they might not agree with the mandates that your tool is imposing. So how do you get around that? Like, how do you make people adopt the tooling that you're developing? Well, you're going to have to invest in 2 things. Firstly, you're going to have to invest time in making sure that this tool is as obvious and easy to use as possible, so there's really no reason for people not to use it. And secondly, you're going to have to provide awesome support. So any problems that are encountered are solved quickly, and developers don't find their processes blocked waiting for your tooling to work with their systems. So, like, if you're thinking of rolling out this type of tooling, you really have to be prepared to dedicate a whole team to it because it's going to take like a lot of time and effort to build it properly, and then a lot more time and effort to maintain it. The second tool we're going to look at is called the screwdriver tool. Now, this is a tool that focuses on solving just a single problem, so it's very small in scope. And for an example of this, we're going to have a look at something I hope most of you are familiar with, which is Capistrano. So Capistrano does one thing. Its goal is to provide you with repeatable deployments of your application. It's really like kind of a muggle of a tool in that it has like a strong no magic philosophy and relies on tooling that you would otherwise be using if you were doing the deployment manually. So in this case, that's Rake and SSH. But what it does do is give you a way to define these steps so you can automate that process. So for those of you who haven't used Capistrano before, or if you're kind of like me and before this talk it had been so long since I had seen it, I could not remember it, let's have a look at what a deployment looks like. Well, I think Capistrano should kind of be called Configastrano because it's really just config and there's a lot of it. This is just a small snippet of what you would actually need to deploy an application, but already you can see it is far more verbose than what we saw with Kubernetes. Some of these options seem like pretty understandable, especially in that first file. So hopefully I know what my application is and where it lives in Git, so I should be able to do that. But the second file starts getting very complicated. There's this concept of syntax, and I can pick server-based or role-based, and then there's some custom SSH config in there as well. So what this is telling me is that if I deploy my application with Capistrano, there's an expectation that I'm going to have to make some decisions about the what, where and why of the deploying of my application. And then I'm going to have to translate all those decisions into the language of Capistrano. So if we think about that configuration, what is it that makes Capistrano a screwdriver tool? Well, firstly, it's focused on doing one thing, which is running your manual deployment steps on a remote host. It's only making decisions about structuring the configuration within your code and how to connect to your server. And finally, it's not making many assumptions about how you want to configure or run your application. And you can see that by the amount of configuration required. So all of those decisions are being pushed down to the developers. But when should you think about using this type of tooling? And what situations does it make sense for? Well, these are actually a great way to encourage innovation within your teams. And when I talk about innovation, it's not kind of awesome new product ideas. I'm talking about enabling developers to make their own technical decisions so that they can move fast and experiment with new languages or tools or frameworks. Screwdriver tools work really well in these scenarios because they're pushing those decisions down to the developers, so they're generally more flexible and able to be used in a wider variety of situations. So if you think about that Capistrano deployment, it didn't actually care if your app was a Rails app or a web app or in fact even a Ruby app. Its only concerns are that you stored your code in Git and that you could SSH to your server. Because these tools also focus on such a small scope of functionality and they're not making those assumptions, it's generally a lot easier for engineers to understand the mechanics of what the tool is doing. As in there's a chance that they could actually read the code. And that makes it possible for engineers to kind of support themselves in a lot of situations. On the other hand, the problems that you're going to see with this kind of tooling is firstly because it's much less opinionated and you're passing that responsibility down to developers, they're going to be resolving the same problems multiple times across multiple teams and multiple systems. So you've got to be prepared for some duplicate effort to happen. You can also end up with a lot of variance in your systems between how the same automated step works using the same tool because of that difference in configuration. And finally, it's also going to require a certain amount of knowledge from the engineers using it, as they're responsible for all of the important decisions that your tool is not making. Now, the final tool that we have to look at is called the Ducttape tool. So this is a tool that wraps an existing system to provide a consistent interface. Now, generally, you're trying to make an interface consistent over one of two things, either time or multiple systems. So for example, if you're trying to make an interface consistent over time, you might be doing something like wrapping an existing system, knowing that you plan to change the API or even the entire system out from under that wrapper, but you don't want to disrupt too many users in the process. On the other hand, if you're trying to provide a consistent interface over multiple systems, you might be implementing something like GitHub scripts to rule them all, which is good if you haven't seen it, look at it. And that provides a single way to perform common tasks, such as like running your test suite across all of your different applications. So Ducttape tools are generally very business specific. So the example we're going to look at here is actually a tool that was developed by one of my teams at REA. Now, first I'm going to have to give you like a little bit of background on the project and why we went down the path of introducing tooling in the first place. It was actually like, this is quite old, so this was almost 2 years ago now. We had this monolithic Rails app like everyone has called Agent Admin, and you may be able to guess from the name, but it was responsible for enabling real estate agents to change their property listings. But there were 3 big issues with it. First, it was Rails. Laughter, yes. Second, the other problems we had was like setting a development environment up was like really hard. So I remember when I first joined the team, I got it up and running in a day and people were impressed. So it literally took hours to get running. And the second issue was that this project had heaps of different developers from all across the business working on it. So like every time that a new person came along and maybe they just wanted to change a button, but you would have to help them through that setup process, and it was just very time consuming. So our solution to this was to use Docker for CI and development. Because using Docker, we knew that we could achieve that one-step process for setting up a development environment. But there was a big problem with this decision, and that was that at the time Docker was really new at REA. So not many people who were working on Agent Admin had ever heard of Docker, let alone tried running it. So we kind of came up with a solution to that problem as well. And it's like not a very pretty one, I've got to be honest. This is, I've got one person laughing who knows it. This is a bash script that lived in the root directory of the Agent Admin project. And if you have a look in the bottom left-hand corner, you'll get a hint to what it does. This is called bundle. And then if we look on line 7, you can see that it's actually calling bundle from inside a Docker container with the application configured and running on it. So this script is actually just wrapping Docker in order to enable developers to use the technology transparently without having to change their current working patterns. Or like actually learn much about how Docker works, but that's a different problem. So how is that script a piece of Ducttape tooling? Well, firstly, it was providing a minimal layer of functionality around Docker, as we saw, that enabled the use of that technology without having to change any existing patterns. So in other words, it was maintaining that interface over time. Developers were kind of used to running bundle exec rake spec to run their tests, and with this tool, they still could. However, like many Ducttape tools, this one kind of rotted very quickly. So we found that as soon as developers became more familiar with Docker, it kind of became more of a burden than a benefit because it was obfuscating what that bundle command was actually doing. So when that happened, we had to remove it. So when should you think about using Ducttape tooling? Well, this can be a great way to improve the agility of either your systems or your engineers. And that's because it's reducing the friction or overhead of making changes. So they're generally also quite small and contain almost no business logic. So they should be pretty fast to develop as well. But the issues that you're going to see with this kind of tooling is like, firstly, as we saw with that bundle script, it can become obsolete very quickly. So you need to either plan for this to be a temporary fix or be prepared to maintain it frequently. As the system that you're wrapping changes, you're going to have to change your tool as well. Additionally, like the value that it provides can be quite questionable. So you kind of need to ask yourself, is this tool actually going to help people or is it just obfuscating the system that it's wrapping? Like when I think back to that bundle tool, I still kind of wonder, could we have just written some nice documentation about Docker instead of like a whole script? And did we even need to introduce Docker so quickly in the first place? Could we have waited a little bit longer? So how do you make that decision? Like, how do you know if your tool is going to be a burden or a benefit? Well, you need to ask yourself, like, if you did not introduce this tooling, could you realistically support the number of systems or the number of people that are using your system, especially if you're going through a change period? And if the answer to that question is no, then introducing tooling could be a really good idea. So that was it, the final pattern. You've now got 3 of them in your like imaginary tool belt. So let's do a quick review and have a look where they all fit in. So firstly, we saw the Swiss Army knife tool that combined multiple individual functions behind a single interface and was an awesome way to improve the speed of your delivery or development processes. Then we had a look at the screwdriver tool that focuses on solving just a single problem and it can encourage innovation within your teams. And finally, we saw the Ducttape tool that wraps an existing system to provide a consistent interface and can improve the agility of both your systems and engineers. But kind of, as we saw before, all of these have drawbacks. So if we look at the Swiss Army knife and the screwdriver tool, well, they're going to require a lot more support. While the screwdriver and the Ducttape, well, they need more knowledge or proficiency from the people who are using them. And the Ducttape and the Swiss Army knife tool, well, they're really inflexible. So you're not going to be able to use these tools for much more than they were originally designed for. Now, hopefully, like next time you're facing a roadblock with your delivery or development processes, don't just like do it manually and go to the pub and try and forget about what you've just done in the corner. We've all been there. Think back to this talk and like think about what's actually driving the issues that you're facing. Like, is it a problem with speed, you know, an inability to innovate, or a lack of agility? So think about those problems and then find a way to automate around it. And then you can go to the pub with a clear conscience. So thank you everyone for listening. That was my talk. Again, I am at Deutscher on Twitter.